Hi, my name is Corrin Ricketson. I'm from Thomas Edison State College, a nuclear energy engineering technology program. I'm here today to do part 3 of a group presentation, Nuclear Renaissance, Fact or Fiction, with Shelley Wolford, Eric Brilliant, and myself. Today's outline consists of current utility outlook, future developments, license extension for existing nuclear power plants, power uprate modifications for existing nuclear power plants, small modular reactors, and an overall conclusion. Currently, the United States has 104 operating reactors at 65 nuclear power plants since 1996. 65 of those plants are pressurized water reactors with a combined capacity of over 64 gigawatts. 35 of them are boiling water reactors with a combined capacity of 34 gigawatts. Nuclear power provides about 20% of the nation's electricity. Here's a map of all the reactors in the United States, operating from 0 to 40 plus years based on color. We've got some in California, the Texas Midwest, and the Eastern Coast. Here is a graph of the projected and actual construction costs for nuclear power plants between 1966 and 1977, the number of plants made, the projections based on thousands of dollars per megawatt, the actual cost in thousands of dollars per megawatt, and the percentage overrun running between 109 to 281% over the estimated cost. That's 3 times the amount of a predicted cost for a reactor plant. Future developments. The Department of Energy predicts that in 2040, the demand for electricity will increase by 21%. 5% will be used from nuclear power, 37% will be coming from natural gas, 20% from wind, 18% from coal, and 12% from solar. Now here's a graph of the estimated levelized cost for new generation resources in 2016 using 2009 megawatt hours. This is a total cost with overnight capital cost, fuel cost, fixed and variable operation and maintenance, financing costs, and an assumed utilization rate for each power plant. Here is advanced nuclear, right kind of in the middle, a little bit cheaper than solar and wind, about the same price as coal, and a little bit more expensive than gas. The natural gas combined cycle, the next generation capture technology. The government wants to reduce emissions by 28% by the year 2020, so they will be charging a $45 per metric ton emissions cost if they're used, which will benefit the nuclear power because they don't have any emissions, therefore they might actually become cheaper than coal and gas in the future. Future developments. In 2007, Tennessee Valley Authority, TVA, was granted permission to reconsume construction on the Watts Bar 2 power plant that they stopped construction in 1985, most likely due to economical reasons. Since 2007, there's been 16 new licenses applications for 24 new reactors throughout the United States, although due to the cost of building a reactor, probably only 4 will see operation. Currently, these 2 power plants have been granted their licenses in 2012 and are currently under construction. They are the Southern Nuclear Operating Company with a units Vogtle unit number 3 and 4 in Georgia, and South Carolina Electric and Gas, the units VC Summer unit 2 and 3 in South Carolina. In order for the government to entice companies to build nuclear power plants, they came up with the 2005 Energy Act with a couple of incentives. The biggest one being a loan guarantee providing $18.5 billion towards construction of a nuclear power plant. Now this is just a budget. Once that budget is gone, there is no more funding for other nuclear power plants, and that is about the cost of maybe 2 power plants to be built. There's also a production tax credit reducing 1.8 cents per kilowatt hour for the next 8 years, or 6,000 megawatts. That helps alleviate some of the costs. There's also a standby support liability protection due to startup delays for obtaining the licenses, construction delays, whatever the delay may be, it gives them a liability assurance for that. License extension for existing nuclear power plants. The current contract for power plants is 40 years, but with the NRC's permission, they are allowed to operate for an extra 20 years, depending if the company wants to keep the reactor operating. They may shut it down due to construction, if the maintenance is too expensive due to steam generators breaking or what are leaking. They may shut it down due to the economy, if it's just not economical to keep it operating. But the ones that do want to renew their contract, it takes about 30 months to 5 years, so they start early on it. The NRC goes through 2 phases. It goes through a Title 10 Code of Federal Regulations Part 54, which is a focus on safety and the management of the nuclear reactor and the adverse effects of the aging reactor. And the second part is a Title 10 Code of Federal Regulations Part 51. It deals with environmental issues for operating a reactor with an additional 20 years on it. The plants will put together a package, and the NRC will go over it, will evaluate that, the plants and the paperwork. A public hearing will be held, allowing the public to have access and provide questions and their opinions if they don't want to have nuclear in their neighborhood anymore. Since 2013, the NRC has approved 73 licenses. They expect they have 18 more licenses, paperwork been submitted, and about 7 more anticipate to apply. Power uprate modifications for existing nuclear power plants. There's 3 different types of uprates, ranging anywhere from 2% to 20% additional power. The stretch power uprate provides about 5 to 7% additional power and yields an average $14.2 million a year extra, so that it's a good return on for the cost. It usually is performed on pressurized water reactors. It includes changes to the operating procedure, technical specifications, adjusting set points, and replacing minor components. The other small uprate is a measurement uncertainty recapture power uprate, MUR, and it increases about 2% power. It's the smallest, quickest uprate, and it's basically a ultrasonic feed water flow measuring device developed in the 1990s. It provides an accurate calculation of reactor power for safety analysis of reactor designs, thus allowing the plants to operate closer to the limits because they now have an accurate measurement to tell them if they are near or over the limit. And the last one, the extended power uprate, EPU, provides up to a 20% power increase with a return rate of $37.8 million a year. However, it does cost $100 million to put the uprate into effect. They're normally occurred on boiling water reactors. Their large power increase comes from change of balance of point components, such as steam generators and other large components. If the uprate is occurring during a refueling process, they can also upgrade the advanced fuel design, providing a longer life capacity for the fuel. Currently throughout the United States, there has been 30 measurement uncertainty recapture power uprates, 40 stretch power uprates, and 30 extended power uprates. The NRC predicts in the next 5 years about 35 more applications submitted to them for uprates. Small modular reactors. These are probably the future of nuclear reactor plants because they are cheaper to build due to their smaller output of 45 to 640 megawatts. Because they're smaller, they have a smaller capital investment, and they have a site flexibility to be able to put on locations that don't have a lot of land or a grid that doesn't require a lot of power. They can even be put in the backyard of a huge company that just needs their own power. They're built underground, which allows for safety and security measurements, especially after 9/11. That's on the public's interest very high. The module means that the nuclear steam supply system will be built off-site at a factory with experienced technicians so they can mass produce them. They understand the quality assurance of operating with nuclear-grade equipment. Once the modules are put together, they'll be shipped most likely via rail car to the factories where they'll be fueled and then put into operation. The government really wants to see these reactors operational, so they gave the Department of Energy a 5-year contract for $452 million towards the research and development of approving small modular reactors. There are currently 2 companies in the running for the current grant with NRC, and that is the B&W Power Reactor. They are a 180 megawatt pressurized water reactor. Their advanced light water reactor design uses natural phenomena such as gravity, conduction, convection to cool the reactor in case of emergency while it is underground. They've submitted their paperwork to the NRC for license approval, and hopefully by 2018 will be approved and have an operating reactor in Tennessee in 2022. The other company that's close and running behind them is NuScale, and they're a completely different design of reactor. They have a 1 to 12 45 megawatt module, independent module, all independent on their own. They have their own reactor vessel, pressurizer, steam generator, turbine generator. So if maintenance is to be done on one module, the other 11 can continue operating, which is great for the company because they don't need to now shut down the entire plant to do maintenance. That way they can still produce power and make money. Worldwide, there are 131 small module operating reactors. Currently in 7 different countries. There are 14 under development. So as you can see, it's going on worldwide, and it's a great advancement for the United States to pick up on. In conclusion, just go a recap of everybody's presentation. Shelley went over winning the public's trust, trying to combat legacy issues, explaining new issues such as the Japan accident in Fukushima, trying to win back the public's trust because currently 38% of Americans are against nuclear. Eric went into research and development, fuel advancements, extracting uranium from the ocean, new reactor design such as the fast breeder reactor. He went into safety advancements. When the accident happened in Japan, NRC went over there to evaluate how they can prevent accidents occurring over in America. He also touched on fusion and how if we can capture the sun's energy, we will be able to have energy for the rest of our lives. I went into the current utility outlook, kind of compared it to natural resources and the cost of building new reactor plants, license extensions, extending current nuclear power licenses, performing modification upgrades on licenses, and talking about future developments and small modular reactors, which could be the future of the company. Some of my resources. If you guys have any questions, please email us. My name again, Corrin Ricketson, part of Thomas Edison State College. Thank you very much.